Okay, as you can see, this trio needed a little doctoring. I made a beautiful problem, and then I tried to mess with it, and I broke it. So notice my fixes. I've changed the number out in front to a 2. I've changed on the right-hand side the sign in the parentheses from a minus to the plus, and I've made that coefficient of b a 6 on the right-hand side. And then in the last one, I made a 14 right next to the equals. So this is a trio. These are supposed to go together so that you can see something that even if you've seen it before, you might have forgotten. It's kind of a funny little detail with linear equations. So we're just going to go for it and see what happens along the way, and then I'll talk about it as we run into weird things. I think I've correctly built the first one so that we don't run into weird things, but we'll check it out. So what I'm seeing is there's a B, hold on, let me switch colors from what I was doing. A B trapped in parentheses and brackets on the left-hand side, a B trapped in parentheses on the right-hand side, and another B that's not really trapped anywhere, but will need to be combined with the other ones. So my first goal is to clear the parentheses and brackets so that my B won't be stuck anymore. And I'm going to do that by distributing. On the left-hand side, you can choose whichever set you want to distribute through first, either the parentheses or the brackets, but I would say it's generally a good idea to work your way from the inside out because it can get a little confusing about what to distribute through in the brackets. So I'm going to go ahead and do this parentheses first and say I have 2 times 3 minus 4b plus 4 equals 1 minus, so that's supposed to be 6b if that's looking confusing, so it's 12b. What am I doing? Minus 2, so that's a minus 10, and a plus 6b still hanging out at the end. So I still have 3 b's floating around. I think I'm going to go ahead and do a little bit of combining like terms, just to clean things up a little. 3 and 4 is 7. So anything you can do at this point to clean up some mess is a step in the right direction. And I have negative 6b minus 9. Okay, so I have one last set of brackets that's still trapping a b, so I'm going to go ahead and distribute through that set of brackets. The other thing you could do to get rid of the brackets is divide, but generally that makes more mess than distributing. That'll build in fractions, which I'd rather not create if I don't have to. So I get 14 minus 8b equals negative 6b minus 9. Okay, last step before I can switch back to the methods of the previous section is I need to get my b's on one side, and it doesn't really matter which side, so you take your pick. I'm going to go ahead and move my b's to the right-hand side. That's supposed to be a b, which means I need to add 8b to both sides. So I'm disconnecting the negative 8b from the 14 by adding. All that's left on the right-hand side is 14. Nope, left-hand side, sorry. On the right-hand side is 2b minus 9. And now I can finally go back to 1b on one side, reverse order of operations. So b is being multiplied by 2, and then I'm subtracting 9, which means the first thing to go is the 9. To get rid of a 9 that's attached by subtraction, we'll use addition. 14 and 9 is 23. And then we need to get rid of the 2. It's attached by multiplication, so we'll divide by 2 and say b is equal to 23 over 2. Okay, so nothing too weird going on there. As always, it's really good if you can check your answers. So I'm not going to do that, excuse me, for every problem, but you should at least every once in a while jump back and practice so that when you're doing an exam, you're pretty efficient about being able to check your answer and see if anything's wrong. There won't be extraneous solutions to linear equations. That only happens when you multiply in extra variable stuff. Okay, so the second one I've made some little changes to. Notice there's not a b all the way on the far right. In the brackets, I've changed the 2 to a 3. I've changed one of those numbers. That might be it for now. So let's see what happens. See if I correctly fixed my problem. So I'm going to start off the same. I'm distributing a negative 3, so I get negative 6b plus 6. And then on the other side, I'm distributing a negative 2, so I get negative 12b. minus 10. Okay. And then I'm going to combine some like terms before I do any moving around. On the left-hand side, I have 3 plus 6 is 9. On the right-hand side, I have 1 minus 10 is negative 9, and negative 2. Oh, hold on, I got more than that. I was expecting that 6 to have a number, but it doesn't. Okay, so I have 1 minus 10 plus 6, so 7 minus 10 is negative 3 minus 12b. Okay, now I can get rid of the brackets by distributing. 18 minus 12b is equal to negative 3 minus 12b. And maybe you can start to see the weirdness. My next step should be to get all my b's on one side. So I'm going to go ahead and add 12b to both sides. And what happens is there are no b's left over. I get 18 equals negative 3, which is definitely a false statement. What this is telling me is that the solution to my equation does not actually depend on b's. While it was kind of buried in there, there are the same number of b's on both sides of that equation, so that doesn't contribute to whether or not it's balanced. The b's always balance each other. So the question at that point just becomes, do the constants, the 18 and the negative 3, balance each other? And they definitely do not. So the answer to the directions here were solved. So what we should be saying is this equation has no solution. If you would like to, you are welcome to use empty set. That's saying the solution set of this equation has nothing in it, is basically what that means. So either one of those is fine. So this is called a contradiction. I don't care if you remember that. I think I brought it up in the last section, but that's what's going on here. We have a statement that's false no matter what values of b we use, so that is a contradiction. It has no solutions. Okay, let's look at the last one here and see what weird stuff I hopefully have going on here. So same start. I'm going to distribute a negative 3 through. So I get negative 6b plus 6. Did I have a plus 6 last time? I did. Okay. And on the other side, I think that might be the only change. That's become a 14. I have minus 12b minus 10. 10 plus 6. My pen is going crazy. Okay. And then I'm going to do a little collecting. So I have 2 times 9 minus 6b equals 14 minus, oh, what am I doing? I'm supposed to be combining. 14 minus 10, which is 4, plus 6, which is 10, minus 12b. I don't think I succeeded at all in building this problem. I don't think my 14 was big enough. Okay, well, we'll go one more step. So I have 18 minus 6b is equal to 10, 18 minus 12b is equal to 10 minus 12b. And I just built another contradiction. That's not what was supposed to happen. I even worked it through and checked it. Okay, so let's see. Here's what I wanted to make happen. What would we need? I think this would need to be 24 is my trouble. Nope, I think this would need to be 22 is my trouble. So pretend there was a 22 out in front. And when we combined, we said, okay, 22 minus 10 is 12, plus 6 is 18. So this is an 18, and this is an 18. And you get this funny statement when you're all done where, again, you can continue to the next step if you want, but I think maybe you can see right now it doesn't matter what b you choose. That's just a true statement. Those things are equal for any value of b. So if you want to go the extra step, when you try and move your b's to one side, you get 18 equals 18, which is a true statement. So this is an identity, and again, I don't care really if you remember that name. What I care about is you know what that means about your solutions. So if you're trying to solve an equation, your variables drop out. That means the solution doesn't depend on the variable at all. So you're either going to have a infinitely many solutions or a no solution. If the statement you're left with is false, that means no matter what you plug in, the statement will be false and it has no solutions. If the statement you end up with is true, that means no matter what b you plug in, the original statement will also be true. So this has infinitely many solutions. And there are variations on this that I would be fine with. Infinite number of solutions. In this case, it's actually legit to just say all real numbers. That's true. There can be some exceptions to that even when we have identities, but for this one, totally valid. Any b you choose will be a solution. So this is something to just continue to be aware of. This is different than the extraneous solutions issue that we've talked about a little bit before. That'll come up again. This is not that you got a solution and you threw it away. It's that you didn't end up with a standard solution at all. You ended up with either an always true or always false statement, and you had to draw conclusions about your solutions. So hopefully that makes sense. Thanks for watching.